shopping men's jeans, I'm perfectly happy to type men's jeans, not please, sir, could you direct me to the men's jeans department? Right? That's not. I have not added anything by that longer form. I think that there's a there's a big question mark in my mind as to whether for simple needs that map quite well to entities, which in turn map quite well to keyword search, the idea of a conversational, natural language, generative AI powered experience makes sense. Not that that's stopping folks like Walmart and Shopify and perhaps even Amazon from trying. Now, with that said, I do see a huge role for AI in making the experience better, but generative AI in particular, I think may be a little bit of a sledgehammer for that problem.
So let's tease that apart here, right? Because generative AI in search, right? There's a couple different places that we can apply AI and have it, to your point, be effective. Um, One of the things that has really been instrumental, as we've been in search and been search practitioners for decades now, the whole problem of natural language understanding has always been a challenge, right? There's always been approximations. We solve it with synonyms. We solve it with with heuristics and lexical solutions, right? But AI now gives us a way. So aside from the generative side, AI gives us a way, right, to deeply engage with content understanding. How are you seeing AI solutions on that side of the coin, not so much on the summative side?
Yeah, so I think that, well, first off, I think a lot of the interesting thing on the sort of summarization side or what have you happens on in indexing. For example, you can take all the reviews that have been posted for products and summarize those in a good review, or you can do a lot to improve the just the representation of the product in general at indexing time, and that's great. I do think that the uh, on the query processing side, it's a little bit different. I mean, one of the problems I've been very excited about is recognizing that multiple queries mean the same thing. As an example, if I'm looking for a cable to connect an iPhone to headphones, something that Apple invented the need for when they removed headphone jacks, then I might call that a Lightning to AUX dongle or an iPhone headphones adapter or any number of things that all mean the same thing. And lexical solutions don't do particularly well there because if you try to pepper your dictionary with synonyms, you're unlikely to get all those things right. But it gets even worse than that. Imagine that I'm looking for a small or large espresso cup versus a small or large beer mug. Those It's not like you're going to want small or large to map to particular sizes measured in volume. Those are different in the context of the things they're describing. So those are many cases where getting query understanding right, figuring out what to do with these queries is not going to be as simple as taking the tokens and then mapping tokens or phrases into tokens or phrases on the other side and matching them. But in contrast, a small espresso cup being mapped to, say, a 1 ounce, or forgive me if it's, I can't quite get it in milliliters, say a 30 milliliter espresso cup, is the same thing. But AI can do that, right? You can get that out of representations that you obtain using large language models. So that's not a generative case, but it is a case of using the foundational models in order to obtain semantic representations of query intent, and that I found to be extremely powerful, even in those simple needs in e-commerce.
Yeah, no, completely agree. And I think that was the same experience that we had building Scopus AI at Elsevier, is when you started to do searches that were across domain. So when you started looking at, like, what's the relationship between titanium and lung cancer, for example, right? You ended up getting nothing back that was useful, because when you looked at those solutions, there was no literature that really kind of captured any of those relationships. But when you looked at it across a vector space or across an embedding space that had a semantic representation, and it knew that titanium was an alloy, and it knew that wasn't necessarily lungs, but it was actually looking for different internal organs, right? It could expand that semantic. We almost got it for free without having to build out a large taxonomy of rules that said, yeah, when I say small in this context, I mean 15 ounces, but when I say small in this context, I mean 15 milliliters, right? Beer versus, and so building all those rules out used to be someone's full-time job, and we found that that the semantic encoding can really capture that in a very nice way.
I'm also curious, in the e-commerce setting, the things being indexed are exactly the things that people are buying. In general, there are some exceptions, but people aren't looking for information, they're looking for products. I imagine specifically the Scopus case that the information need someone has doesn't necessarily map one-to-one to an article, and that, I imagine, has some impact on the approach you took.
Yeah, no, that's exactly right. In fact, when you looked at, well, first of all, we had a very different problem as well, is that we had everything was long tail, right? So the whole query pipeline was long tail. The biggest queries that we saw were AI, right? Those are the most popular queries, right? Or marketing, or right. And so the only things, everything else was sort of just a dribble. And so it was really impossible to kind of look at the data to help us figure out what people's intent were. And then when we actually sat down with users, right? What was happening is, because the system was a keyword system, instead of it being a flywheel where it was accelerating discovery, it was a dampening effect. And what happened is the more words that they would put into the search box, the worse the results would be. And so we were actually training users, right, behind the behavior of the system, to just put in a few words at a time, and use the filters, maybe use date, filter by what's free to read, or filter by what I know I can subscribe, so I could find something that I could read. And when you started looking cross-disciplinary across the multiple disciplines, there was no connection there whatsoever. And when we put this vector search capability in front of researchers and editors, the overwhelming response was, wow. This is game changers. This entirely changes my workflow. I don't have to do all this work to work around the system. I can just ask what I'm looking for and build connections, or ask for connections that I wonder exist, and it's finding them for me.
Yeah.
But on the e-commerce side, though, do you have how does that map to the AI, because I imagine the content is relatively sparse, right?
So that depends, right? I mean, I've worked for e-commerce firms with inventory in the many millions, so it's not that sparse. That actually, you end up with different problems, right? If you think at one extreme, if you're an Amazon or an eBay, you have enormous catalogs. So there's a decent chance that whatever somebody's looking for, not only do you have one thing that matches their intent, but many. At the other extreme, imagine, say, a catalog like Netflix, where they don't have anything from Disney, but people will look for Disney movies there, and they have to show something reasonable. Actually, they're an interesting case in that they do represent content they don't have in order to recognize those intents. Similar situation with, say, restaurant lookup on a site like OpenTable. But what I found, there were a few things that I found that were interesting. One was that even though I had sort of grown up thinking the big challenge was when somebody types in a query and you don't know what they mean, it's ambiguous, like Jaguar or Java. Those situations are cute, but they're primarily academic ones out of the information retrieval literature. The more interesting case will be that people will type in the same intent in many ways: men's shoes, shoes for men, gentlemen's shoes, and so forth. And you want to capture the similarity among those intents so that you can aggregate the signal and make use of it. The other thing is that, and it gets back to your point about sort of dampening the signal, there's a distinction between what people want and what people say, not because people are lying, but because people are, well, sometimes they'll express themselves in whatever way they know how. Sometimes they'll default to using whatever the autocomplete nudges them to. Sometimes they're lazy about typing. Sometimes they don't know how to spell and so forth. So you have to be careful about equating what they type in their queries to their intents. You want to make sure you're able to surface their intents. And you should sometimes think, nobody is just looking for shoes. They have something more particular in mind. And in those situations, you have to do some work to tease that out of them. So even though you may sometimes think, wow, they have this super broad exploratory intent, it's like, no, maybe that's just all they know how to type in, or they're afraid if they type in more, the system won't support them. So there's a bit of a chicken and egg, particularly when you look at the potential value proposition of a conversational interface, or of being able to understand a very elaborate intent. That requires work on the part of the user, that requires trust. They may learn not to do that. You may have to lead them along a path to get there.
Right. Yeah, no, you're absolutely right. When people come in to any search system, they have a different context in mind. And, I remember having debates with the team about, well, if someone comes in and we can recognize them again, right, we can apply that context the next time they come back. And the reality is, right, and we all know this from having done this for a while, that the same person can come in and have a different context. Some days you're like, yeah, I want blue pants. And the next day they come in and say, that movie with with John Travolta, those pants, right? I want them, and they just have whatever context is in their mind that they're bringing to that experience. And I think as part of that search experience, as part of that application, to sort of tease that out and say, what do you mean, right? What are you really trying to get here? What's the goal for you today?
Yeah, I'm looking at some of the questions coming in. I want to pick, there's a good one, which is, what's the advantages from Amintri of the advantage of improving product representation versus doing understanding work on the query side. And you clearly need both, but here's a way to think about it. If the intent being expressed can't possibly match what you want in the index, you have no hope. So this is an example that I ran into, where somebody was looking for mason jars, this is for drinking, mason glasses with or without handles. If the product representation doesn't have a notion of with or without handles, it doesn't matter how smart you are about understanding the way the query is expressed. And you can imagine, negation is hard. Handleless, without a handle on the side,
super expensive, right? Yeah.
Yeah, but it won't matter if I know. Imagine we have a conversation back and forth, and I come back and say, "Great, I know exactly what you want. Unfortunately, I don't know my own inventory well enough to figure out whether it is what you want." But you can see at this point that the product representation becomes foundational. Now, that said, you want to improve the parts of your product representation that are being targeted by query intent. So, for example, if I know exactly what materials and the chemical compositions of them and so forth, but nobody cares, nobody ever expresses intents that direct towards that, there is no point in my enriching the product representation. So you want to make sure that you are representing the aspects of intent that searchers care about. Then you need to make sure that you're able to take those representations of intent and match them to the representations that you have. So you do need both content and query understanding that way, but that's the way in which I see them coming together.
So going back full circle on this a little bit, is generative AI a useful set of tools for mapping that intent and indexing time? And how are you starting to think about some of the tools that are and the models that are available now to either to do that or not do that?
So I'm a big fan of using sentence similarity models, these transformer models, to map queries to one another, to get them into a space where I can recognize that queries mean essentially the same thing or have expressed very similar intents. In fact, even mapping queries to browse nodes that way, which is a nice thing in the highly structured world of e-commerce search. So that's a little bit different than the way people think about generative AI, but it's using the same large language models underneath. And but it's more akin to query rewriting or to searching in intent space, finding, for example, the k nearest neighbors among a set of queries that you know how to target. That's a little bit different than getting queries in natural language form and say responding to them or engaging in a conversation. I've seen those sorts of generative experiences do interesting things. And in fact, I hope that someday they become either replacements or augmentations of what faceted search was intended to do, namely to draw out the intent that isn't necessarily fully expressed or understood by the searcher. But where I've seen the most immediate success is in this essentially query similarity.
Yeah, no, that was our exact same experience as well with Scopus AI. The power that we used was a sentence transformer. In fact, we used and the optimization that we made was we optimized for a sentence transformer that was very small, so it saved space in our search index, and also could be converted, embedded very quickly. So we used a mini LM was the one that we had a lot of success with, and it's a high ranking one. If you look at like Hugging Face, it's one of the higher ranking models that's out there, and I think that's going to be something for us to keep on top of as practitioners is which models do we use and how do we apply them into the right spaces. Because there's going to be the right tool to the right job. Let's put it that way. But yeah, I'm a huge fan of the sentence transformer because if you think about it, right, what someone's asking is they're putting together a sentence. So like, why not map it to the same sort of semantic space as a sentence?
I mean,
So yeah, so
I was going to say that the other thing that you have to watch out for is that depending on your corpus, right, queries and documents can look quite different. Now, in e-commerce, you might think, well, at least, hey, queries are short and product names are short, but product names are much longer typically than query names. So we had to play some games there. And I mean, there are variety. There are two tower models. There's things like Cobert. But what we ended up doing was something that my colleagues' work that I did with a colleague at eBay called the bag of documents model. Thinking of a query as essentially the mean of associated document vectors, which it turns out to be an approach that extends beyond e-commerce. And then essentially training a contrastive model on we started from head and torso queries for which we had a relationship between queries and documents. We built a bunch of training data. We used that to build a contrastive model to generalize the tail. But we were able to put effectively queries and products in the same space that way. And that turned out to be really, really powerful. We published that work and that was nice.
That's super powerful. I mean, I think, think about how many times we try to cross multiple domains and we, federated search days, we would kind of take it, we would tease it apart and run it in separate spaces. Someone asked me what was the name of the model that we use, and the model I'll write it down or I'll put it in the chat in LinkedIn. But the model that we used from Hugging Face was Mini LM V12. So the Mini LM model is the one that we used.
Coincidentally, the same one that we used for the work on semantic equivalence at eBay. So one of the fascinating things to me is that these models aren't just interesting because they're powerful, but there's a bit of a transfer learning effect that's going on where you're leveraging that somebody has essentially scooped up so much of the world's knowledge and use that to give you a baseline. Though I'll say there, you have to be careful as well. If you're working in a consumer enough domain like e-commerce, or even as it turns out from Eric working in something like with Scopus, which is a little bit more specialized, you can get a lot starting with general knowledge. But if your domain is highly specialized, your mileage may vary there, and you may, it's worth looking at either things that are pre-trained for your domain or bite the bullet and do your own fine tuning.
Yeah, do your or do hybrid. It's a great caveat, and I'm glad you shouted that out because where we saw this pre-trained model based on internet content, it's trained on I think over a billion pieces of content. Maybe it's 8 billion. I can't remember off the top of my head. But where it failed pretty dramatically was on things like chemical names or compound names or internal names. So you would imagine brand names that are not in the public domain, things that are talked about internally. Those were areas where it wasn't able to recognize it, and so that's where you need that little layer of intelligence where it says, listen, let me go into the vector space, let me understand if this maps into something that I recognize. If not, take, as you said, a different approach, right? Maybe a hybrid approach. Maybe lexical and TF-IDF, good old TF-IDF, good old BM25 is fantastic for some of these, these names that aren't in the proper space, that don't really have a semantic representation.
Yeah. Well, I mean, it was actually a question about interpretability of the approach, and so when I was at Endeca, we pushed very hard for the value of transparency. And if you think about structured data, faceted search, it kind of goes in that direction. And I kept preaching that until I, was involved in training my first query classifier based on fast text, one of the earlier large language models. Maybe it doesn't even count as large anymore.
Yeah.
And then I said, well, here's the thing about interpretability. If you get it right, nobody cares. And if you get it wrong and say, I'm sorry, here's why, they care a little bit. So it's sometimes more important to be right than to be interpretable. It depends. And if you're in a domain, say like legal, that may not, or medical, that may not be as true, because the consequences of being able to explain yourself matter a lot. I would say that as your systems get more complex underneath, you lose interpretability. And then you have to start thinking about, well, at least can you give answers that are simpler to understand? One of the nice things about the sort of the query similarity problem is that you might not be able to explain why, say, the cosine between these two queries is, 0.97235. But at least you're saying, I think that your query is similar to this query, and you can understand what this query is. Very similar to when Netflix recommends something to you and they're saying, well, it's because you like this other movie. Exactly why they're not explaining. They're not giving you the internals of what the model was doing, but they're giving you something to work with. And I think that interpretability is starting to turn into more, give me an explanation that's truthy enough. It's not that it's made up, but it's an oversimplification, but that you can hang on to. I think the bigger problem, though, with working with vector-based search versus traditional keyword-based retrieval is that inherently with a vector-based approach, by the way, to be technically, Jared Salton back in the 60s was using a vector-based approach, even with things like CFIDF. But but with these dense vectors, that you're inherently using cosine similarity as a sort. And you're saying, I'm going to get the nearest neighbors to my query and pick a cutoff somewhere. And where you pick that cutoff is somewhat arbitrary. In contrast, when you do keyword search and you say, I've got to match all of the tokens, or I've got to match at least 3 out of 5 of the tokens, that may actually be just as arbitrary, but at least you know what you're doing, and you put a cutoff and you have a retrieved set and it has a count and you can make facet counts on it and that sort of thing.
Right.
It feels a lot more arbitrary when you're doing it with is cosine 0.6 enough, 0.7. So I think that problem is a bit more gnarly in the vector case, that it's not clear whether what you're doing looks like retrieval or looks like sorting.
Yeah, no, I think that's an excellent point. I mean, I think to your point, there really are two different use cases, right? So when you're doing a keyword search and you're saying exhaustively, go through the database and create me a facet, I really want to know, how many mason jars do I actually have in my catalog, right? How many different vendors of ping pong balls are there in the catalog? I think when you're applying vector search, at least this is the case that we used for the Scopus search, we were really trying to say, okay, we're going to try to surface the best answer and not try, and if you want to go off and find out how many authors have published papers, about the intersection of computer languages and physics, right? Go do that somewhere else, right? If you want to find all the experts in the world that are biologists, in studying plants and studying the change of plants through the seasons, that's a different query that you should be doing somewhere else. But if you want to use vector search to summarize something, that's a different experience. And by creating that summary and creating that reference to that content underneath, you're saying, listen, I'm trying to help you, right? I'm trying to help you summarize this content because it's very deep, but please go back and verify my results for me, right?
Yeah. No, I mean, it's there are a lot of ways to mix these things. I'm actually looking at one of the questions here, which is basically, can you use LLMs as a reasoning layer to let models tune relevancy? And part of this is tricky. I think a lot of us have come in with the starting point. Keyword search was doing reasonable things, but largely like it was missing things. A lot of the attractiveness of using vector search, using or EBR, as somebody else asked, embedding-based retrieval, is to increase recalls, to get things that otherwise the model wouldn't get. And I've certainly seen a lot of value there, right? Where, the traditional approaches like synonyms and query relaxation that you might use to get increased recall pale compared to what you can do by holistically understanding the query intent through embeddings. On the other side, I've seen cases where if you look at the cosine scores that your vector search approach would return, regardless of how the items were retrieved, right? But if you just look at the cosines, they'll say, look, I don't care if this matched your keywords, it just doesn't seem like what you have. And that can protect you in situations where, for example, keyword reordering drastically reduces the relevance of what's coming back. I would say that if your model is well tuned, if your embedding model is well tuned, your cosines should be pretty reliable. And the main reason that you don't use vector search for everything is that it's too slow, and maybe you care a bit about the sort of interpretability, but that if it says, and this is at least my experience, if your vector-based model says something isn't good, it probably isn't good, regardless of whether keyword search retrieved it. So it's a bit of a hare and the tortoise situation where keyword search tends to be faster. It works a lot of the time. It's typically its biggest failing is on the recall side, unless you aggressively tune it for recall, in which case you've thrown precision really hard on the bus. Right. While using vectors, it's better at recall. Actually can do quite nicely in terms of the precision recall trade-offs as well, but it's way slower, especially and it's especially slow on easy problems in a sense, right? If you're retrieving a lot of things, the just nature of retrieving things in this nearest neighbor way compared to using an inverted index is really painful. So if you think about it, vectors help you in the cases where you probably wouldn't have gotten that much stuff back unless you really leaned into recall. And the only way to lean into recall without throwing precision hard under the bus is with a holistic approach. Vectors can save you there. If your problem was easy, your query was easy, you already have a lot of stuff, vectors are probably just going to slow you down.
They could, right? And I think you're right. It's in those sort of more complex cases, those more nuanced cases where it adds a lot of value. The other thing that this question makes me think about too is that I think there's starting to be a model and architecture that I'm starting to talk about with different clients where we have a number of different relevancy models behind the scenes, right? So, we just talked about two, right? You have your sort of your lexical, your BM25 index, and your vector index, right? There could be, but there could be an architecture where there's multiple models. In fact, there could be a graph database, there could be a Mongo database, there could be another NeoSQL database, there could be a pure vector database, and these all could have different representations on your data. And I think one of the things that's really intriguing about this concept about using the LLM is the LLM could sit there as an intermediary, right, to start to understand the question, right, to understand the intent, or have that conversation to like, let's iterate to the intent because it's not clear enough, to then redirect your query towards the right backend repository that can fulfill that question the best. So, for example, in the case we talked about earlier, someone comes in with a very specific query about like a drug name and a manufacturer, right? That's probably best served by the knowledge graph, right? So don't send that to the vector search engine. Don't try to figure out what the semantic representation is between the manufacturer and this drug name, because it's probably not going to exist. You're better off just going to the knowledge graph, finding all the instances of that drug and bringing it back. And I think that's an opportunity that we're starting to see emerge as a new pattern. I don't think we have a name for it yet, where these agents start to participate in this collective discovery of your content in different ways.
I mean, we had names for very simplified versions of these things. We called them things like source selection, or the variety of sort of, and I see a few questions along these lines of basically saying, hey, when a query comes in representing a task, the first job of it is to essentially figure out, planning that task, orchestrating it. I mean, even at LinkedIn, something like, are you looking for a job, or are you looking for a person, or are you looking for content? And your retrieval strategies and your ranking strategies will probably be quite different, right? If you're looking for content, maybe you want recent content. If you're looking for people, maybe you want people who are in your network. If you're looking for a job, maybe it's one that matches your skills. So, and maybe, by the way, you really want a mix of these because you want content that's, what interview questions do they use that job, and what people do you know at the company where they're hiring. And at that point, I
Right.
could certainly see
I want a
that.
semantic interpretation of the hiring
Yeah,
manager.
you want that
Exactly.
trust.
Yeah, another
Um,
great example. I agree.
I think that that's something that where historically search has done poorly, and that it's pushed that problem into the application layer. It said, look, that's not a search problem. That's a search application problem of sorts. We're not, it's not information retrieval. But of course, now we're getting better at this, and we're saying, no, it is. Somebody expressed an information need, and this is essentially, can you synthesize based on what's available the best way of meeting this? And this is the promise of LLMs, right? The promise of LLMs ultimately is to do all this and even better infer and say, you should apply to this job. And by the way, I've deep faked a video of you answering the interview questions correctly, so you're good.
Right.
But
Exactly. So you're an expert now. Go ahead.
but I think that in the short term, that may come down to saying, well, I'll come up with the different strategies for each of these things, and I'll send them out. I mean, there are also simpler things. Somebody asked about, where does RAG fit into this? Your retrieval augmented generation, which
Was it
is
this one from Jacob?
I think so, yeah. And I mean, on one hand, for those of you familiar with things like pseudo relevance or blind feedback, I love the idea that you do a query, get results, possibly from the corpus you're looking at, possibly from another one, and use that to improve your query. That was one of the old-fashioned ways of doing query expansion, in fact.
Exactly. You go into a taxonomy, you go into another repository, or just a smaller classification that you could then go and expand, right?
Yeah. I think the big question is the order in which things happen. So if you, right now, I think the pattern you see most is basically do a query to your to your your repository documents, largely to sort of get a sense of the vocabulary. And then once you have that, hit your LLM or hit ChatGPT, what have you, in order to say, hey, by the way, like, this is the proprietary knowledge I want to throw in. But you still have the risk of hallucinations in that sense. The other way around, and I've seen this actually in somebody doing this on top of Semantic Scholar, where they hit an LLM first to rewrite the query, and then they go to Semantic Scholar slow as molasses, but you will get back real documents because it's the final stage in that process is document retrieval rather than a generative one of creating sentences. It won't be as exciting potentially as a nice abstractive summary you could have gotten, but you're guaranteed it's grounded in real content. So
yeah, no, exactly. And well, it depends again, that depends on your use case, right? In an academic case, you really want it to be grounded. Even in an e-commerce case, you want it to be grounded. If you're asking for advice or something like that, or asking for something that where it's a little bit looser, then it's okay to have suggestions. So just on that one of the things that we did that helped to refine queries a bit is this notion that we came up called RAG Fusion, that like Llama Index picked up and they put into the framework. And RAG Fusion effectively takes a query, throws it to the LLM, and says, okay, be creative, right? Come up with things that I may have asked that are in this space. Run those queries in parallel, and then use RRF, reciprocal rank fusion, to then bubble up the ones that sort of surface across the various ones. And it drove up some more precision or accuracy inside by being able to run those things in parallel. So
the baseline I would ask for that, and this is one I've struggled with, is basically an LLM can do really powerful things with essentially playing with your query. A simpler approach can be find me the most similar queries from a set of known queries, just using straight nearest neighbor. I've had a lot of luck with that in cases where essentially your tail query is really just an unusual way of expressing something similar to a more headish intent. But that will fail when, there are related queries I should process for you, but they're not similar in that sense. They're just related in a way that maybe a graph could represent and so forth. So I would say that I do like the similarity-based way of getting things because it's cheaper, it's simpler, it's understandable, but it does have a limit to the expressivity. And I'm guessing in some of your applications, you needed the more powerful one.
That's right. Yeah, no, absolutely.
We have a lot of questions.
And in some cases, again, this was a use case where we were trying. The use case I was talking about for React Fusion was really about trying to build broader summaries, right? So it wasn't about finding that document or that answer. It was still in that generative solution where we're trying to create basically an abstract on the fly of a set of results. And so in that case, we came up and said, yeah, highly caveated. This is generated automatically on your behalf. Here's the underlying content that supports these assertions and with references throughout the documents, but it's still a summary of this sort of nebulous topic that we're going after. So,
Yeah.
Wow, I can't believe it's been 40 minutes already. Let's take a look here and see if there's any other questions. I love that you're pulling out some of the questions throughout here. Let's do that.
Somebody asked about image search. Yeah, right. So generative AI in the context of image searches. And the fascinating things with image searches is that, now the question is, are you searching for an image or do you want to create one, right? So the old school, before generative AI was around, a lot of image search amounted to, near duplicate detection. And then, of course, you started to see more abstraction of that so that you could draw a picture of a cat and actually find cats. And some of that was a bit of a smoke and mirrors because the underlying representation wasn't necessarily one of an image, right? It was more getting it back to an abstraction.
It pulled text from around the image, right? It sort of did that higgery jiggery to kind of find an image. It wasn't actually understanding what was in the image, right?
Yeah, there's no question, clip models and the sort of thing are we're basically saying, hey, let's have nice multimodal models so that essentially, when you enter text, you can get useful images, and there's no question that LLMs have helped a lot there. I do think that what's I don't know, as we move into a future, will the input be text? Will the input be an image? Will it be some kind of a mix? And will we, how important will be the problem of sort of finding an image that exists versus varying that image in some way versus creating one from scratch? I'll admit I'm more of a text guy myself.
Yeah.
There's, certainly the representations of images using large language models. That's I can't see any other way. They have made images discoverable in a way that was impossible before.
It's impossible. The fact that I can go even on my phone and search for cats or dogs or cars, and I'm literally, I can't remember. I have a car rental, and I can't remember what the license plate is. So I can search on my phone for a picture of a car, and there's my car that I rented, and its license plate's right there, so I can look at it. Right? Simple sort of mnemonics that are totally completely helping me out.
Yeah. Although actually, one point there, images like large documents may have a lot of things in there, right? So the if you look at I'm looking at my own picture right now. I think it's a picture, of a balding man or whatever, but you could argue it's a picture of a glass door if that's what you're focused on. And so there is this issue of image segmentation and what it is you're interested about it, which can be there as well. So there is that added layer of complexity, which can also happen in just longer documents.
Right. And I think, and to your point too about multimodal models, right? I think we're going to get to a point where my guess is that we're going to get to a point where it's seamless and you're going to go in and say, hey, I'm looking for a picture of a cat, right? And it'll come back and say either I have a picture of a cat or it'll say, well, let me just generate one for you, right? Because I can do that as well. And that's where we're seeing that modality and obviously in things like ChatGPT. So this is an interesting one. The intersection of prompt engineering. And we'll take maybe one or two more questions, then we can wrap it because I think we're getting to the end of our time here. So for us, I want to hit this one real quick, and then I want to get your point of view on this one, Daniel. Prompt engineering was a massive part of the Scopus AI experience. In fact, we did a lot of wrestling and as my team used to call it, frankly, a lot of alchemy, right? Because we were doing a number of things like trying to optimize queries for ChatGPT 3.5 because of cost and speed and performance when they worked very simply, and there was a lot of intent understanding in GPT-4. And full disclosure, we used OpenAI as our LLM for our solution. So prompt engineering, and it turns out that with some good prompting and good prompting, that you could actually get GPT 3.5 to behave with high level of quality and a high level of precision, but it really took some convincing, right? You had to be pretty strong with the model. And I think my current take is that's where we are now. I'm guessing that that's going to evolve and become, it's a very important thing right now for building AI and generative AI solutions. My take is that that's going to become less important over time. What's your thoughts on prompt engineering?
Yeah. I mean, prompt engineering reminds me a little bit of SEO. Like on one hand, clearly you have to do it. The results ultimately speak for themselves, but it's not fun playing with something where it's almost impossible to know what's going on in the black box underneath. And in some sense, isn't the whole point of something that understands you that you express yourself as yourself, not by manipulating the prompts? Now, that said, sometimes it makes a certain amount of sense to say, oh, yeah, this is the context I should be supplying, or something that's obvious to you, but like sort of reasonably would not be obvious to the language model. I think so. I haven't done as much specifically, say, with ChatGPT with the OpenAI tools, but when I've worked with large language models, I've certainly played with what the representations would be. For example, when search queries come in, one of the bits of feature engineering that we've done is to run a separate query classifier and add that, concatenate that with a separator character to the query. Theoretically, the model already knows that. It's actually powerful enough it should be able to do that on its own. But this is a way of saying, hey, by the way, the category matters. Should I have to do that? Technically, it's not adding more information, but I can tell you the quality improves. So there's a bit of this nudging that I think we've always done in search, where some of feature engineering is not necessarily saying, I'm going to tell you something you don't know, but it's more like I'm going to hit you over the head with it so that I force you to focus on it. And one way or another nudges the loss function in the direction that it should go. I can't say I'm proud of having to do that, but we're going to be doing that sort of stuff. But I agree with you. These models aren't supposed to need that.
Yeah.
And so I see this as a stopgap, not a long-term thing. So
I just
those
want to, I
of
just
you
want to
who are
share this,
thinking of
this,
having your
this
kids
comment.
major in prompt engineering, don't do it.
This is a great comment from Steph, right? It's an adventure in non-determinism. That's why I was smiling.
I
That's why
love
I
it.
come through.
I
This
love
is a
that.
great comment, Steph, and I completely agree. But I think it's a really good symptom of where we are now. So let's wrap this up, Daniel. Let's go back to the original premise of what. So we started off and says, generative AI, the future of search, right? And so I think this can be interpreted a lot of ways. Is the LLM, right? One way to interpret this question is the LLM going to be the new search engine?
So I think LLMs are here to stay. I do not think that the interaction pattern of generative AI makes sense for situations where, one, what you want back looks like an indexed document, not like a piece of information or an abstracted thing, and two, where honestly the amount that you need to express to get what you want is simple and small, and you're better off. When I go to Starbucks, I'm not a big fan of Starbucks, but it's a good example. I had this experience when I said, hey, can I have a 16 ounce medium estima blend coffee? And they're like, what? Because I didn't speak the domain specific language of
You didn't
Starbucks,
say it.
right?
You need a venti latte with a half calf, double
Yeah,
calf, triple calf, whatever.
yeah. So my first reaction was, stupid baristas. And then I realized, no, it's not. They're not the problem. I'm the problem. It's me. But I should learn the language that everyone has learned to optimize for this interaction because it is more efficient. It works. It's unambiguous. It doesn't run into these problems. At some level, we should not be using natural language to make the problem harder rather than easier. We shouldn't be using conversation to make the problem harder rather than easier. I think that there's still some merit in sort of the retrieval and ranking paradigm that search has pushed. That said, in places where there's a lot more that searchers can bring to the table, then it will be better. And then maybe the craziest take of all, if we could use voice, but at the same time having a natural human to human style interaction in a video context, then I think things change a lot. There isn't the pain of typing. There isn't the awkwardness of interacting with a keyboard or machine as if it's a human. So I actually think that the day, if it comes, where we interact in VR with human-like avatars to do our interactions, is a day like Neil Stephenson predicted Snow Crash, when things will change.
So as we wrap, I think that's a fantastic point, and I think it's really about moving forward that paradigm. How do we interact with these data systems? How do we make this more? I'm not gonna say more human, but more accessible. But tell me, ask me one question. Have you put on headsets and used the mobile version of ChatGPT 4 and had a conversation with it yet?
So I have I've played around with ChatGPT powered voice to voice interactions. I even tried something on my Quest 2, but it's very slow, right? Like the uncanny valley is tough. If there's that second or two delay, that kills it.
Yes.
So we
So
really,
I'm gonna leave you. I'll stop. I'm gonna cut you off right there. Very few times I'm gonna do that. I'm gonna leave you right there. I'm gonna say, Daniel, go do this for me. Go get the mobile version of ChatGPT 4, plug in some headsets, and just say, hey, let's have a conversation and ask it anything you want.
yeah,
I want to hear your reaction to that.
fair
And
enough.
we're gonna leave everyone with that because it's honestly, it's starting to get not the patch ChatGPT forward powered applications, but the OpenAI version of the app itself. Go give that a whirl. Um, this has been an amazing conversation. Tons of great response from and questions and engagement from everyone. Please let's keep the conversation going. The stream is going to be recorded. It's going on YouTube. It's live on LinkedIn. Continue to have that conversation here on LinkedIn, and yeah, give us some feedback and let us know what you thought. And thanks so much for joining. And Daniel, thank you for joining me on this conversation. It was really, really just great to catch up with you and get your thoughts about this. I saw one comment go by saying, "Oh my God, it's Daniel live." So I
Michael,
thought
thanks for
about.
that.
I feel like if we accomplish anything, we just had a conversation with Daniel. So thank you so much for doing it with me. And I had a blast.
Thank you, Eric. It's been a pleasure. Take care,
Bye,
everybody.
everybody. Thanks so much for joining.